Occasionally, I will get distracted from my day-to-day things and real life by finding some puzzle or problem and obsessively focusing on it to the point where I can't really do anything else until I've conquered and finished the job or the task. This in particular is one. It just so happened I thought I was done recording a bunch of malware videos for now, but then I noticed a couple recent ones that came in. I was looking at them, and two of them in particular were very similar. The emails are both emails from myself with an attachment, just a basic simple attachment saying here's your file or your file is ready or nothing at all even. And the code for them both contained within there, obviously it's a JavaScript file contained within those attachments. There's no pictures, there's no PDF. But the code itself is very similar. Even the very first variable in the file is declared the same. They've got the same pattern throughout. We've got some new interesting things I haven't actually seen before. Prototyping functions. We have an awful lot of words. Basically, looking at this code, I think the computer script that wrote it has a bigger vocabulary than I do. And of course, at the end, we have some encoded characters here as well. The only real difference between the two of these is that one of these contains an evaluation of something and the other one doesn't. I'm going to process this file just for the extra evaluation code that's in here. The nice thing is, because these are very, very clearly generated by the same systems or used by the same type of system, we've now got a chance of doubling the payload, the same type of payload that's going to come out of this in the end. Let's take this one and save a copy here as photo. Okay, so the first thing to do with this file is let's just take it into the JavaScript beautifier and make sure that all the formatting is good and look for the encoded strings. There it goes, decoded our strings for us. Took care of some indentation issues that were out. Okay. So I'm going to spend probably quite a while at this, going through and getting rid of all of the extraneous text that's contained within these bracketed part where we know we only take the final term from them. So there is an awful lot of vocabulary in here to get through, a lot of broken up strings to get through, so I will do that first, and then I will resume recording. Done. Okay, so I finished with the discarding of all of the extraneous words in order to reduce down the strings. And I've done some string concatenation where possible, producing strings like that from piles and piles and piles of brackets, pulling out only one or two letters at a time. Now the rest of what's left requires some additional string processing that isn't quite obvious. Some of it is here, so what we can do is replace the SEO and the 8 with an EAM. Similarly here, we're going to have a feel at this point that should read as response body, and that most likely weasel is going to be the letter E for giving us get. So the patterns become quite obviously despotic, probably an S for send. So let's look at getting into some of those functions. This is an interesting array construction. This one I'm quite surprised to learn of its existence. I like the way that it works. This is effectively a shortcut or a select case condition where basically you can look up the first component and get the return value of this back or a line of code. It basically allows for case selection execution by calling the array itself. So effectively, this is going to look up the U, return a capital letter S, we return the capital letter S to a lowercase s. So we're going to replace the R with the S, which is right here. No big surprise there. You get the word substring. Pretty much what we were seeing that word almost read. Anything else we can replace with down in here? Replace the U again with an S. That's how we're able to get the response body out of there. Anywhere else? Yes, right here. This thing called helper foot. Now, it turns out that a prototype function is part of JavaScript that allows you to create a new function to apply to every single type of an object. So in this case, we're going to be adding a new function called helper foot that can be applied to any string object, the same way that a join or split or reverse or length operation can be applied to the strings. We're adding one that will be applied to the prototypical string object. So what does this function actually do? Well, this is going to be the actual string that's passed into the function to operate on. This is a loop that is going to loop through each element that it can find within this pod whatever array. So in other words, for both of the colon and U, it will do these operations. And what it will do is it will take the string that we're going to input and it will replace the colon with the lookup for the colon, the dot, and it will replace the U with the S. Where do we use this helper foot function? Only in one place. And what do? We replace colon with dot and W with S. And we now no longer need the helper foot function. Okay, what about this helper foot 2? Well, first of all, some variable 2 is going to be 1. Unseemly is 0. Use this constant other places. I don't think we use that anywhere else, but I'm going to keep it for the moment. Okay. The interesting thing about JavaScript is the way that it allows interacting between method/function, especially properties and methods of an object. You can address them as you would this, the join function with the dot join or dot split, or you can have an object and then in brackets, square brackets, use the string form of it. So this is effectively the same as the dot substring command. So what we're going to be doing here with this function is making a temporary variable that will return the original string put into the function, this object, for the lookup for chime. So we look up webmaster chime, that returns the function we're going to operate on. So that's the equivalent of this. This is whatever we pass into it. We're going to take this first one character, and we're going to return that first character back. So all that helper foot 2 is doing is taking a long string and returning the first character only. We now have no need for helper foot 2. Okay. Also, throughout the program, they have a bunch of randomly named variables, and they just assign them numerically increasing orders, F10, F11, F12, F13, etc. This seems rather odd. There doesn't really seem to be a need to address them. Also, because of the fact that I do have code in here that is contained within a eval, means I could be addressing some of these functions, but a quick look over at the other script that was identical to this one or similar to this one showed that they had no references to any of these strings either. So these are just simply filler garbage. So I'm going to clear that space out right now. Okay, and now let's go ahead and actually, do I need this function anymore? Extra thing? No, I don't. Unseemly. Does it change? Does it get used? Nope, we're done with it. Yeah, we'll get rid of that for now as well. Okay, so let's start using these strings back here again that we had. Excitement, P. Replace with Spottic is an S. So as we expected, this is send. Well, better hold on to that because I don't want to get ahead of myself here with these eval statement. I might be getting too far ahead here, but the way these things usually work here for these strings, I'm gonna assume I can clean these up. Is this used? Garbage name like that, when every other variable name has high order of readability, means, you know, it can't be that garbage stuff. Okay, any more excitement or despotic used? Let's clean them out. I'm sure we'll recognize a P or an S missing from something if we decode the other strings. Okay, let's evaluate here though. 100 plus 11 is 111. 111 as a character code is the small letter O in ASCII. Take the reverse of O and you get the word open. That's our battleship. We don't need to join it with anything. We just simply have that remove is that. Remove is the word open, so we put the word open there. Where'd it go? Into here. No longer need this. No longer need that. Okay, I'm just going to take a moment here to clean out all of the line spacings on these things and reorder some of the functions. Okay, so I just reorganized the file a little bit, moving the prototype function out of the middle of the code and getting rid of all the spacing here. So this is all the bulk of the code. Bottom and on the top we have all of the encoding string mess. So what I'm going to do for the moment now is break aside and write up a little web page for hosting this code that will take care of this helper foot for function, because looking at it, it's going to involve a lot of single character byte encoding and then shifting and bit manipulation just to come through and break them down and spit out one at a time to produce whatever the string is. So I don't want to try to mess my way through that. We're just going to simply have the JavaScript tell us what does this string become. So we'll quickly jump ahead to that. Okay, so I've finished pulling out all the strings that need to have the helper foot evaluated, put them down at the bottom of the document, and I've commented out all of the code that would actually run to generate objects and download things here. So the only part of the code that remains are the function declarations for the prototypes and the decoding parts that we need access to. So provided I didn't make any typos in here, we'll find out in a second. I made a mistake. 2 is missing the quote. I'm going to take this back to the file now. I'm going to make the replacements of these strings within the program, and then we'll pick up from there in a moment. Okay, so I've made the one-to-one replacements for those encoded strings, which means we no longer need to have the eval here. Eval just simply means replace the contents with actual code, or, you know, pretend it was code that you were actually running, which is just the same as putting the code there. Changing the string content to code. And we now have no further need for helper foot 4 because everything has been decoded. And these were only used within the helper foot 4 function. Now that everything has been pushed out, do we need this prototype? No, don't need that function either. Clean that out of the way. Oh, and it looks like we did have a need for some variable 2. Well, that was a 1 before, I believe. It was the 6 divided by 6, I think. Okay, so that's a pretty strong reduction right now. So let's go ahead and replace these strings where they are. Percentage is not used at all. Prelude, okay, we're going to process these things to get these strings. Okay, so not too bad, down to 27 lines so far. We need to do a bit of processing to pull these strings out. Again, this is an interesting concept because I haven't actually familiarized myself with this before. The way that these structures work. The shift function works on an array by pulling the first element off of the left of it and leaves behind the remainder in the array. So the array would represent this whole line. Pop command takes the very last one out of the array, a round bracket shouldn't be there, and puts it here, leaving everything that came before it. Now, inauspicious here, we're splitting, so that means we're going to end up making this into an array of 2 strings divided by that character right there, not including that character. Inauspicious 0 is the first part. Inauspicious 1 is the second part. Any more inauspicious use? Nope, so we don't need that anymore. Okay, let's continue with the array. We shift it again, so we now take the leftmost off and put it here. We then shift it again there, so we're taking this part. And we do another shift, pull the exe off through here. And one final shift, which would pull out the only remaining thing, which is that. Okay, so push me now is empty. And undesirable is this plus an exe on the end. Now, let's make these substitutions from here as well. This is the scope of the program. The first 4 lines, and then multiple as an instruction. The function multiple doesn't get called until we call it here. We're only calling it once, and we're calling it with these parameters. I'm just going to move this to above it for the moment. So modeling is this variable. And the felicitous is this one. Now we don't even have to have this wrapped in a function anymore, because running it only once is the equivalent of just simply running this code once. Again, the try and catch structure seems to be required whenever you're having an input and output systems. It'll automatically demand it to be there, otherwise it will throw errors. Okay, so we're finally starting to get to the very end here. This becomes quite obvious. This is our ActiveX object. Our ActiveX object is used to create our system shell object. Well, this one we know is a internet connection request or request object. And this clearly is the expanded form of the temporary folder for the user. So this is a temp folder path. What happened to the file name? Must have accidentally undone or something that. That was the second argument. Well, that was a bit of a setback. Okay, so all that momentum bashed, just like that. So undesirable is our file, our exe file to write. Now again, this false parameter here on this open operation for internet request means to not do it asynchronously, meaning it's going to wait until the send response gets the page type back, which is where this part then comes in. I can only imagine that this probably evaluates to true, and this variable is not defined anywhere, so its type is undefined. So the only part this is really testing here is the status. The status being the server response code for the page request. So if the page is found, then go ahead and do the writing in here. And if it's not, then it just simply falls out. Impulsive is very recognizable at this point in time as the data streaming object or data streamer object. And that appears to be the entire code. So there we are after deobfuscation. This is all that remains of this code is 20 lines, which will download a file from this location. Let's see if there is a payload at that location right now. Nope, unfortunately that page is gone. Site is still there. Okay, but I did say that because there was the other one still, I have a chance of doubling the payload possibility. And clearly this only tries one site when we do it. So let's just quickly run this part because we know that this is the part that calls the function with the parameters. So this is the big ugly string. This first part is obviously going to translate into HTTP. I use a completely different function within there, but it would have translated the same part just by analogy. Then we take still one more part of a string, and then that would be its file name part. So let's see if this page exists. And unfortunately, no, it does not. However, the site is correct. Several newer constructions within JavaScript that I was unfamiliar with or vaguely familiar with. Nice to see them put to use and how they get worked out. And unfortunately, no payload in either case. That's okay. I've got enough payload stacked up for another day.